Welcome to today's class. We're looking at integration and we're looking at how to use substitution to do integration. Now we'll begin with the standard integration, which you're already familiar with, before we generalize to other types of integration. Now, so you must be aware, so let's begin with the standard integration first of all. Now, so you are aware that if you're given an equation of this form, dx, to integrate, that you'll add 1 to the power and divide by the new power, and then add constant of integration. So what I mean is that the integral to this will be ax n plus 1, and then divided by n plus 1. So we are adding 1 to the power, and then dividing by that new power, then adding constant of integration. So this is basically what we know about integration of equations of this form. Now, this rule is applied for all values of n, for all values of n except n is equals to -1. So n here is any number except -1. So for instance, if you're given x raised to -1 dx, then this rule will not apply. We'll look at how do we integrate this, because if you were to add 1 to -1, you would get 0. So, and then divide by 0. And we know that we should not divide by 0 at any given time. So this rule will not apply to integrals of this form where n is -1. So I just want to look at a few examples before we generalize this. So let's look at examples. So we begin with the easy examples. For example, if you're given to integrate 5x raised to 3 dx, this is 5x raised to 3 dx. Then what we'll do, we know that 5 is a constant, so we just write it. But now x raised to 3, we add 1 to 3, shall get x raised to 4, and then divided by this new power 4, and add constant of integration. We can have another example. If you are asked to integrate 13 times the integral of 7x raised to 2 dx, then we know that, okay, this 7, let me just delete the 7 here. Let me delete the 7. I wanted to have the constant outside the integral. So let me just delete this 7. Measurement. Let me delete the 7. So I wanted the constant outside the integral sign. So let me just rewrite this question. And the question that I want us to integrate is 13 times the integral of x raised to 2 dx. X raised to 2 dx. And we know that the answer here, 13 is a constant, so just write it. But when it comes to x, we know that it's raised to 2, so we add 1 to 2, get 3, then divide by that 3, and add constant of integration. What I'm doing is I'm applying this rule. This is the rule that I'm applying. Let's look at another example. The other example is supposing I'm given the integral of 7 divided by x raised to 2 dx. So x raised to 2 is in the denominator. For me to do this integral very well, I must take it to the numerator. So I must first of all have it as the integral of 7 x raised to negative 2 dx. So I must first of all take it to the numerator before I do it. I integrate. So when you do this, 7 is a constant, I just write it. But this is x raised to negative 2. Negative 2 plus 1, you'll have negative 1, and then divide by negative 1. Divided by negative 1 plus c. If you want, you can write this as negative 7 out of x plus c. 7 out of x plus c, negative 7 out of x plus c as the solution. So you can do another example. Let's just take one more example here before we proceed to integration of trigonometric functions. So let me do it here. D. I want the integral of 7 x raised to 3 plus 8 out of x cubed plus 9 out of, let me say 9 times the root of x, everything multiplied by that. Now, so what is the solution to this? So again, the only problem I have is at this point, I have to take this x cubed to the numerator. And so this integral is the same as this. It's the same as the integral of 7x cubed plus 8x raised to negative 3 plus 9x raised to half dx. So it's the same as this. Once you write it this way, it becomes very easy to find the integral. So that the integral becomes, I add 1 to the powers. So 1 to this 3, I would have 7 x raised to 4 divided by 4. Then plus 1 added to this, negative 3, I would have 8 x raised to negative 2 out of negative 2. Then 1 added to a half, I would have 9 x raised to 3 out of 2. A half plus 1 is 3 out of 2. And then divide this by 3 out of 2. Divide this by 3 out of 2. Then add a constant of integration. So what does this simplify to? So I want to simplify this. So let me simplify this and see what we get. So this gives me 7 out of 4 x raised to 4 minus 4 out of x squared. If you want, you can leave your x as the numerator in the numerator. And then this would be plus 6 x raised to 6x raised to 3 out of 2. Then plus 3. I hope you know how the 6 has come. You see what I have there is 9x raised to 3 out of 2. And then I've written divided by that. That's the same as times 2 out of 3. So that 3 goes into 9 thrice. 3 times 2 is 6. And so this becomes the answer to this question. This is the answer to this question. So we can look at one other example. can look at one other example just to make it clear. Example E, let's have the integral of 3x squared plus 7x cubed divided by x squared dx. So for me to do this, the first thing I do is to simplify this. So if I do simplify this, so what I would have, dividing each of the numerator by x squared, I would get 3. This 3x squared divided by x squared will be 3. 7x cubed divided by x squared will be 7x. 7x dx. And then just integrate now. These are constants. So this is the same as 3x raised to 0. This is the same as 3x raised to 0. So if I were to add 1 to this power, I'll get x raised to 1, then divided by 1. So what I mean is that this would be 3x. That would be 3x. And this is x raised to 1. So 1 plus 1 is 2. That is 7x squared divided by 2. And then you would add constant of integration at that point. I want to share another blank space for the other examples. Let me unshare this first, then share another one. Now this time I want to look what is the integration of trigonometric functions. That's what I want us to look at. Integration of trigonometric function. So let me just share space that we'll be using for our workings. That's okay. So let's look at want to do integration of trigonometric functions. Now, so very important to us, we must know that if we are given a trigonometric function, what will be its integral? What will be the integral of that trigonometric function? For instance, if I'm given a sine of x, the integral of this will be negative cos of x. If I'm given cos of x, the integral of this will be sine of x. And you already did this under differentiation. So you know what the derivative of cos of x is. You know what the derivative of sine of x is. So this time we're looking at the integrals. So the integral of sec square x, of course there's a dx there. It will be tan x plus constant of integration plus constant of integration plus constant of integration. All of these formulas are in mathematical table, SMP mathematical table. So you can find these formulas there. The integral of sec x tan x would be sec x plus constant integration. We have also cosec square x. The integral of this will be negative cot of x plus constant integration. So I just want us to look at a few examples to use these formulas. Where we can apply these formulas is just look at a few examples. So the first example, I want us to do the integral of 2 cos x dx. So this would be very easy. This would be very easy. Just if I was to take the constant outside, this would have the half. And I know what the integral of cos of x is. We've already said in our formulas that this is sine of x. So this means 2 sine of x plus constant integration. Now let's make it a bit harder and see. Let's make it a bit harder. Supposing I was given 7 cos of 3x dx. You notice that this is not one variable. This is bigger than x. So we have x here. So you cannot say that this is. Cannot say that the integral of this is sine x or something. So for this one, for us to do is, you can say let 3x be u. Let 3x be u. Now, you then differentiate both sides to find that 3dx is du. So what I want to do is to substitute this dx and substitute this 3x. So that I have one variable here. I have cos u. Once I have cos u at this point, I can know that the integral of cos u would be sine of u. And I also want to change this. I want to write everything in terms of u. So what this gives me is that what I then have is 7 cos u. But instead of dx, at this point, if I was to make dx the subject of the formula, I would get dx to be du out of 3. So instead of dx, let me write du out of 3. So I've substituted everything, I've written x in terms of u, everywhere x appears. Now let me write the constants outside the integral sign. So if I was to write the constant outside the integral sign, it's what I would have 7 out of 3, the integral of cos of u du. Of course, this one we can do it. We are familiar with this from our formulas, that this is 7 out of 3 sine of u plus constant of integration. But we did not have u in our question, so we must substitute it. U was 3x. So what this means that our final answer therefore would be 7 out of 3 sine of 3x plus u. So this is how we do this problem. Now, a few things to note about this working and the answer that we obtained, so that we can see whether this question can be done mentally or in an easier way. What you notice is that my constant 7 and 3 are here. These are constants 7 and 3. And you notice that the integral of cos is sine. and 3x is still there, then plus c. What this therefore means that we can generalize this. We can generalize this working and say that suppose we are given the integral of a cos of dx, we can write the answer straight away as a over b. A over b, and then integrate cos to get sine bx, and then add constant of integration. So I want you to know the working in part B, and also know the generalization of this working. So I'll give one example just to emphasize this, the working in part B, and also use that example to emphasize this general statement. So let me give this example C. Example C, I'm asked to integrate 8 cos of 9x dx. Of course, you know the answer from this generalization. But let's use working in B. We said let 9x be u. Let 9x be u. And then differentiate both sides to get 9 dx. 9 dx as du. Let me just unshare and then share so that I can see my pen has some problem here. Just unshare and then share so that it's not shaking. Just unshare just a minute and share this and then share it so that my pen might without shaking. Let me share it again. That's okay. So what I said is that just as we did in example B, we call this to be u, and then differentiate both sides to get 9 dx equals to du. And at this point, we made dx the subject of the formula. So dx becomes du out of 9. We then come to our integral there and substitute. So what we have is 8 cos of u, because we call 9x, we call it u. Dx, you're writing du out of 9. Du out of 9. The next thing we did was to take the constants outside. This would be 8 out of 9. The integral of cos of u du. So what this gave us is 8 out of 9 sine of u plus constant integration. Of course, we know what u is. We come back and u was 9x. So this would be 8 out of 9 sine of 9x plus constant integration. So of course, again, we see very well that the answer is 8 if we use our generalization. 8 out of 9 sine, the integral of course is sine. This is 9x plus constant integration. So it's very easy that this kind of question you can do it mentally. Somebody can do it mentally. For instance, if I was to give you this, I know that you can do it mentally. If I was to say this is 13 cos of 3x dx, you can straight away say that this is 13 out of 3 sine of 3x plus constant integration. Likewise, if you're given cos of 90x dx, you can say that this is, you see, the constant here is 1. So 1 out of 90 sine of 90x plus constant of integration. So it's very easy doing this kind of integration. Let's look at the integral of sine. Of course, we know what it is from our formulas above. We know what the integral of sine would be. So I just want to give an example that if I'm told to integrate, or just a minute, let me do another example on cos. Suppose I'm given cos, somebody may ask, what about this? Minus 13. Minus 13. Suppose I'm given this. Yet, somebody would ask, what about this? I'll just do the same thing, that let 2x minus 13 be u, and then differentiate both sides to get 2 dx is equal to du, and then make dx the subject to give you du out of 2, and then come and substitute and say that this will be cos of u. The whole of this, we call it u. But what about dx? We are calling it du out of 2. Du out of 2. Then take the constants outside. That's a half the integral of cos of u du. And what do you get? It is a half sine of u plus constant integration. Then bring back your u. U was 2x minus 13. So this will be a half sine of 2x minus 13, and then add the constant of integration. I think that's what I wanted to add there. So let's now go to sine. And after doing sine, we discover that we can generalize the way of integrating to other trigonometric functions. Can generalize to those other trigonometric functions. So let's look what that was an example of. So what about this? The integral of 3 sine of 3 theta d theta. So I would say let 3 theta be u, and then differentiate both sides. This will be 3 d theta is equal to du, and then make d theta the subject because we need to substitute it here. D theta will be du out of 3. Then come and do integration now. This will be the integral of 3 sine of u. Instead of d theta, you have du out of 3. Du out of 3. And you notice that these 3 and that 3 will cancel. Otherwise, you would have taken the constant outside the integral sign. But if 3 and 3 cancels, what we have is the integral of sine of u du. But the integral of sine of u, we said, is negative cos of u plus constant integration. But what was u? U was 3 theta. U was 3 theta. No, 3, yeah, 3 theta. So that is negative cos of 3 theta plus constant of integration. So generally we say that given the integral of a sine of dx would be negative a out of b cos dx plus constant integration. So we just want to look at a few examples here, because we've done so many examples on cos and just approaching it the same way. So we don't need so many examples. So let me just share this and then share it again. But what you note is that we're just doing it the same way we've done the others. That the reason is the same. So when I share this, and then share. I'm just doing that to avoid the pen from shaking, so that it writes clearly and that there's flow of explanation. I share it again. So I want us to look at another example here related to this. So we look at example H, and we integrating 13 sine of 3x dx. And we know the answer. We know the answer will be 13 negative 13 out of 3 cos 3x plus constant integration. That's the answer. And you can write it just like that. Or if you want, then you can say let 3x be u. Differentiating both sides, you have 3 dx giving you du, and make dx the subject of the formula, which will give you u out of 3. And then come and integrate. This is the integral of 13 sine of u. Instead of du, we write instead of dx, we write du out of 3. And if we were to take the constants outside the integral sign, we'd have 13 out of 3, the integral of sine of u du. And this gives you negative 13 out of 3 cos of u plus c. But u is 3x. So this is negative 13 out of 3 cos of 3x plus constant integration. Now just one more example here. And then we go to sec square. Of course, others will follow the same trend. Let's do this. 7 sine of 7x squared plus 3x dx. So to say let, this is 7 now. Say let 7x squared plus 3x be u. So when you differentiate the left side, you would have 14x plus 3, yes, and let me change x a bit. Let me change this because it requires some higher contents which we lack at the moment. So let me reduce the degree of this. Let me say that this should be 7x, and this is just 3. 7x plus 3. So that this is, we say let 7x plus 3 be equal to, yes, let me erase this. Let me erase this. Okay. So this is 7x. So that when I differentiate both sides, what I get is 7 dx is equal to du. And dx would be du out of 7. And then come and do the integration. This will be 7 sine of u. Remember that u is 7x plus 3. And instead of dx, we are writing du out of 7. Du out of 7. 7 and 7 will cancel out, and you have the answer of negative cos of u plus constant integration, or negative cos u of 7x plus 3. Then add the constant integration. Now let's look at the integral of sec, and of course we'll be doing the same thing. Just be doing the same thing. So let's look at it first. Now, once I've done this, using the formulas above, you can do the integral of cos x squared. You can do the integral of sec. Well, it was sec tan. Sec tan can do the integral of cosec x, cot x, and so on. So I want the integral of 2 sec square for theta d theta. So what we would do, we would say let for theta be u. And so differentiating both sides, we will define that the 4d theta equals to u, which implies that the theta is du out of 4. And then you can come and just substitute. You can come and substitute there. So now is 2. This is x squared. Instead of cos theta, we call that u. And instead of d theta, we call that du out of 4. So when you take the constant outside, you have to get half the integral of sec squared u du. But the integral of sec squared u is tan u. So this will be half tan u plus a constant integration. But what is u? U is 4 theta. So this will be a half. That will be a half. Tan of 4 theta. Tan of 4 theta plus 2. and of course theta plus. So that's how we do that. And again, this can be generalized. This can be generalized, so let's just generalize it. Then we go to integration of definite integrals. Of course, what we are doing now are indefinite integrals because they have no limits. So we want to go and do those that have limits. So generally, the integral of a sec square theta b theta b theta b theta will be a out of b tan b theta plus the constant integration. And you can do several other examples, either using this format or just using this general format, and you will have the same answer. So let's look at how to do definite integrals. So let me share it. Let me share this and then share again. Look at definite integrals. Those ones are the integrals where we've been given limits that we integrating from this point to this other point. But the thing is, once you know how to do the integrals, it doesn't matter whether it's a definite integral or indefinite integrals. So we've already looked at the basics, and those are what is very much important to us. Let me share this page. So just look at a few goals now. We already know what to do. So just look at the examples. So we're looking at integration of definite integrals. And we've said that these are integrals with that have limits. For instance, this we're integrating from a to b x raised to n dx. So we just be doing the same thing. We just be doing the same thing. We know that if we integrate this, of course, the first thing you do is to integrate this, then put the limits. So for instance, this is x raised to n plus 1 out of n plus 1. We then put the limits a, b. So now where there is x, substitute b, then minus. Now when you substitute a, so this will be, of course, this will be b n plus 1, n plus 1 out of n plus 1 minus a n plus 1 out of n plus 1. So what we did first was just to integrate. And then we put the upper limit, and then minus what we get when we put the lower limit. But let's look at a few examples. Just because we already know how to integrate, so just a few examples. Okay, for us. Let's do this. The integral of 3x raised to 2 from 0 to 1 dx. So the answer here, first of all, we integrate this. We adding 1 to the power, then dividing by the new power. There's no need of adding constant integration because this is a definite integral. So let's just put the limits 0 to 1. So this is the same as x cubed with the limits from 0 to 1. Now put 1, it will be 1 cubed. What about when you put 0? It will be 0 cubed. So the answer here is 1. The answer there is 1. And let's look at another example. So I'm doing the integral of 3x cubed plus 7x dx from -1 to 2. So let's first of all do the integration. So the integration there will be 3x raised to 4 out of 4 plus 7x squared out of 2. That's the integration of this. Because we are adding 1 to this power, we get 4, then divided by 4. Add 1 to this power, the power is 1. So add 1 to that, you have 2, then divided by 2. Then put the limits -1 to 2. So what does this give us? This is 3 out of 4. I want to put 2, the upper limit. X is 2. So 2 raised to 4 is 16. 2 raised to 4 is 16. Then plus 7 out of 2. This again is 2. 2 squared. 2 squared would be 4. I've put the upper limits. Let me now put the lower limits. Now put the lower limits. The lower limit is -1. So I have 3 out of 4. -1 raised to 4 would be 1. Then plus 7 out of 2. -1 raised to 2 would be 1. That's okay. Let me now simplify and see what the answer is. We'll now simplify that. Just create some space here. Of course, you can see that 4 goes into 16 4 times. So that this becomes 12 here. 4 goes into 16 4 times. 4 times this will be 12. 2 goes into 4 twice. 2 times this will be 14. And what about it? What I'm saying here is that the LCM is 4. And 4 goes into 12 1. 1 times that would be 3. What about this? 2 goes into 4 twice. 2 times 7 is 14. So what we have, the first bracket gives us 26, and this other bracket gives us, this is 17 now, out of 4. 17 out of 4, which we can simplify to have 4. And what is 26 times 4? This will be 4 carry 2. That will be 4 carry 2. Then this will be 8. 8 plus 2, that will be 10. 1 of 4. So that is 1 of 4 minus 17. What is 1 of 4 minus 17? This would be 7. 9 minus 1 will be 8. So this will be 87. 87 out of 87 out of. Now, I want you to try this. I want you to try this question just before we look at the answer. You try it and then we put it together. I want you to try this. I don't know whether it was good. I want you to try cos of 2 theta. Theta from 0 to pi out of 2. 0 to pi out of 2 is theta. So I need to try this. And then we look at it together. Okay. I think you've already done that. So then we stop sharing, then share. Just stop sharing this. Now, so let's do it. Let's do it together. Let's do this question together. Now, of course, we know how to integrate this. Of course, we know how to integrate this. We know that the answer of this integral is the constant here over the constant here. And then what I mean is that is a half. And then sine 2 theta. And since it's a definite integral, there's no of adding the constant with the question. Let's remember the limits that we're doing it from 0 to pi out of 2. So what do we have? What we would then have would be half into. Now let's put the upper limit. Sine, I don't know if this pen is not writing where I want it to write. Sine 2 pi. But instead of pi, 2 theta. Instead of theta, we put in pi out of 2. So pi out of 2 times 2 pi. I don't know why this pen is writing this way. I have to again stop sharing. And then minus, this time put the lower limits. Remember that I put a half outside. So there's only repeating a half here because it's already outside. So this is sine 2 times 0, which is sine 0. Okay, let me just stop sharing, then share again. Let's stop sharing, then share. Oh, it's not even shared. not even shared. Let me just it's not even being shared. We just have to draw the examples and then we'll stop at that. Let me remember to share it because I discovered that I was not sharing anything. I was not sharing anything. Let's remember to share a screen. Then come and share this. That's okay. But let me just repeat it because I realized that the screen was not being shared. So this is the question at hand. And you've seen that to do the integral of this, you take the constant here, divide by constant here. So the constant here is 1 divided by 2. Then the integral, of course, is sine. So that will be sine 2 theta. Then these are our limits, 0 to pi out of 2. So I now put the half outside. And inside, I now put sine of 2 theta. But instead of theta, pi out of 2. Pi out of 2. So pi out of 2 times 2 will give me pi minus sine of 2 theta, where theta is 0, that would be sine 0. So what is this? This would be a half. So with your calculator, you can find what sine of pi is. And we know that pi is 180 degrees. So if you go to your calculator, then just press sine of 180, you'll find that it will be 0. Sine of 180 is 0. What about sine of 0? Sine of 0, just use a calculator and again find that it's also 0. It's also 0. So that means this answer is 0. It means this answer is 0. And that answer is 0. So if I would have wanted to avoid 0, I would have worked on this 2. For example, if I were to have, let me just look at another example. I want the integral from 0 to pi out of 2 of 7 cos 5x dx. Of course, we now to integrate this inside the integral sign. We know that we have 7 out of 5. And then sine 5x. And we are doing this from 0 to pi out of 2. So what does this give us? This will be 7 out of 5 sine. I don't want to factorize it. Let me just do the way it is. 7 out of 5 sine of 5x. Instead of x, put the upper limit. So this is 5 pi out of 2 minus 7 out of 5 sine 5 times 0. 5 times 0. So what do you get? What is 5 pi? Another pi is 180. So 5 times 180 divided by 2 is 450. What is sine of 450? Sine of 450 is 1. Is 1. So what I have is 7 out of 5 multiplied by 1 minus 0. So the answer is 7 out of 5. Now, the good thing about this integral is that the limits here were angles. What about if the limits are just numbers, not angles? For instance, let me just do an example. So I'm just doing this one example and one can generalize it. Can generalize that. So what if I'm given the integral of 12 cos 7x from 1 to 2. And these are not angles, dx. So this, I know the inside here, I know that the answer will be 12 out of 7. You also know that because you learned that this integral can be done mentally here. So this will be sine of 7x. And our limits are 1 to 2. So what does this mean? This means 17 or 12 out of 7 sine of, let's put the upper limits, it will be 7 times 2 minus 12 out of 7 sine, let's put the lower limits, it will be 7 times 1. But what we notice is that 1 and 2 are not angles. So what this means, what it means when you say that sine 14, this is the same as the sine of the same as, so you see the angles must be in radians. So this is same as sine of 14 radians. Sine of 14 radians. So what does that mean? Sine of 14 times 180 divided by pi. Because what it means that 1 pi radian is 180. What about 14 radians? So it will be multiplied by, so what is this? So this means 1 radian is 180 divided by pi. And we are talking of 14 radians. Yes, okay, exactly. So we are talking of 14 radians. The sine of 14 radians. 14 radians. So this is the sine of 14 times 180 divided by pi. So what is that? 14 times 180. 14 times 180 divided by pi. And pi, you can find that as 3.14 something. It's on your calculator. When you press shift, then pi. So when I do that, and then find the sign of that answer, I find it to be, so this first part, what did I do? What I did is just write what I've written. What I've written, this one I've written it as 12 out of 7 sine of, instead of this 14, I've written 14 times 180 over pi. So that your calculator can do that. And this one also is 12 out of 7. Instead of this 7, I've written, this is 7 radians. So it means 7 times 180 divided by pi. So let's just use our calculators and see what we get. So I will begin by sine then open brackets 14 times 180 divided by pi. I get 0.9906. Then multiply that by 12. Or let me not multiply by 12. Because I want to factorize that 12. Let me just say minus sine of 7 times 180 divided by pi. So I have 0.33362. So it's this answer I multiply by 12 and divided by 7 to get 0. You just use your calculator. It's approximately 0.57192 if I were to write this answer to 5 decimal places. So next time when you meet, look at other types of integration. But for today, I want to say thank you for joining me.